In this session, we multiply rational expressions. We multiply rational expressions a over b times c over d as a times c over b times d. We multiply straight across with the assumptions that b cannot equal 0, nor can d equal 0. When we multiply rational numbers together, 2/3 times 2 over 5, multiplying these fractions straight across, we end up with 4 over 15. One more example with rational numbers. 12 over 18 multiplied by 9 over 24. We can multiply straight across like we did before, and then at the end we can reduce. Or if we take a strategy that will be useful so that we don't end up multiplying large numbers together, we can take this approach. We can factor and then cancel common factors. For example, 12 over 18, well 18 is the same as 9 times 2, and then we're multiplying by 9 over 24, and 24 is the same as 12 times 2. Now I have it factored, and I can see some common factors. The 12 in the numerator can cancel with the 12 in the denominator, and the 9 in the denominator can cancel with the 9 in the numerator. And now we've done all our canceling, we multiply straight across. We end up with 1/4. The same technique will work when we multiply rational expressions together. For example, if we multiply 2x squared y divided by 5xy cubed, and multiply that with 25x squared y squared over 14xy. To multiply these two rational expressions, we want to cancel whatever we can cancel out. So I can cancel the 2 in the numerator with a 2 in the 14 in the denominator, leaving a 7 behind. And we can cancel the 5 in the denominator with 5 out of the 25 in the numerator, leaving a 5 behind. And now we want to look at what can we cancel with the variables. Well, if we look at the denominator, we have an x down here and an x down here. Those two will make an x squared, so we can cancel with that x squared up here. And now what about the y's? Well, we have a y on top and a y square on the top. That makes a y cubed, and that can cancel with the y cubed in the denominator. So now we've canceled everything that we can possibly cancel out. What's left over, we multiply straight across. We have 1 times 5x squared in the numerator is 5x squared. And in the denominator, we have 1 times 7 times y, which is 7y. Suppose we have x squared minus 9, all divided by x squared minus 2x minus 3, and multiply that with x squared minus 1, all divided by x squared plus 4x plus 3. We want to factor everything we can possibly factor, and then we want to cancel out common factors. And then whatever's left over, we multiply straight across. We can factor the first numerator, x squared minus 9, is the difference of two squares. We factor the difference of two squares as a plus b times a minus b. So therefore, we will have x plus 3 and x minus 3 as the two factors. The first numerator will factor as x plus 3 times x minus 3. In the denominator, we have x squared minus 2x minus 3, and we use that strategy of factoring. Since the leading coefficient is a 1, we ask ourselves, what are the factors of negative 3 that add together to give negative 2? Negative 3 is negative 3 times 1. At the same time, negative 3 plus 1 makes negative 2. The factors would be x minus 3 times x plus 1. In the second numerator, we have x squared minus 1. Again, there's only two terms, so we think about special forms or GCF. X squared minus 1 is the difference of two squares. Therefore, it will factor as x plus 1 times x minus 1. Here we have the second numerator is x plus 1 times x minus 1. Now the second denominator, x squared plus 4x plus 3. And we ask ourselves, what are the factors of 3 that add together to give 4? And the answer would be 3 times 1 makes 3, and 3 plus 1 makes 4. Therefore, we have x plus 3 times x plus 1 as the two factors in the second denominator. And now that we have it factored, the second step is to cancel out common factors. It has to come from the numerator of one fraction and the denominator of another fraction, or the same fraction. The x minus 3 and the x minus 3 can cancel out. Or we can take the numerator of one fraction this x plus 3 can cancel with the x plus 3 down in the second denominator. And likewise, the x plus 1 can cancel out as well, leaving an answer in lowest terms of x minus 1 on top and x plus 1 on the bottom.